And Justin came in. And there's Timber. Okay, Justin. I'll get Timber later. So this is what we're working on Wednesday. I said for you to work it so you'd have it ready for class. So I'm going to put up the answer. So there's the answer. So what we did is we subtracted this from that and got that, and we subtract that from that and we get that, and you continue that on and you get all these. And so you don't see any pattern there, so we go to the next, we do the same thing. Next we take 146 minus 16 gives us 130. 606 minus 146 is 460. Continue on. Again, no pattern. You keep doing this. 460 minus 130 is 330. And finally you get down to the bottom here. We see you get 120 for each place. So if anybody has any questions about how we got those. Now, I'm not going to, you can, maybe you'll get them down if you write feverishly. If not, you can always go back and watch the recording and just write it down at that point. So, so to go the other direction, you start here and then move back up. So this is going to be 120 because we have 120 in the last row. And then what we'll do is we'll add this plus 120 to give us this. This plus that gives us, you just continue that on. And so there's how you work the other direction. I know I'm blocking one there, so I'm sorry about that. But, so once you get to a point where you have the same number at each slot, then you can say, okay, I'm done, except I need to go back the other direction. So I take 576 plus 120, which is 696, and then I take 1698 plus 696, and I get 2394. This plus that equals that. This plus that equals that. This plus that gives me my final answer, which is 28,675. So again, what's the usefulness of this? I don't know. I don't know why it flashed there, but it's just, again, I'm just recognizing patterns. We came up with a rule. The rule was that once we get down here and we have the same number, then we just move up the direction. So I think you have 1 or 2 problems for homework, and you can, if you're still not sure about it, there'll be one of these on the test, so make sure you know how to do it. It'll be shorter than this one. I want to take forever to do it. Just so you know, if you get your homework done early, you can turn it in whenever. I'm writing on today's date, so I know when you turned it in. So when I go, if I forget, it depends upon what I'm doing. I may go today and just put all, hundreds or ones. What I'll do is I'll put a 1 if it's correct. If it's not quite correct, then I'll put some fraction of 1. These look all good, so if you've turned it in, I think everybody, so you see the level of detail. Yes, Justin? Pardon me? It's completion, yeah, unless it's not completed, and then I kind of arbitrarily decide how much I'm going to give you. Okay. But I'm not going to go through every individual answer because you can look on the recordings and find out what the answers are. Okay, so that's the method of successive differences. Let's see, go to the next page. And we talked about this last time, just to remind me. So if you take a sequence and you add the terms together, that's called a series. And there are certain series that are used in high-level math for predictors, for coming up with an algebraic expression for things like trig functions or other functions you may not have experienced unless you've taken pre-calculus, which most of you have not. So I'm not going to talk any more about that. So these are kind of examples. They're not really sequences. They're just formulas. If you add numbers together, various combinations of numbers, here we're adding odd numbers together up until some maximum number, which is, so you choose an n, some counting number n. Counting numbers, does anybody remember what counting numbers are? So we'll get more to this later. There's whole numbers, and there are counting numbers, and there are integers. So counting numbers are things you can count with your fingers. Okay. So 0 is not a counting number. So it only counts when you have a finger sticking in. So 1, 2, 3, 4, 5, 6, 7. Those are counting numbers. So this applies for any counting number. I'll give an example here in a second. It turns out if you add all those numbers up, you get a result. So I guess you could use this as an example of deductive reasoning. You know, here's the rule. The rule says if you add these counting numbers up, the result is the number squared. So let's just look at an example. What do you need to know? You don't have to memorize this. You just need to know. If I gave this to you and I said, you know, what's the answer? You'd have to just use it. So if I said, you know, if n equals 5, I could say 1 plus 3 plus 5 plus, well, let's see, we have to know how far we go up. So we plug in the last term, which would be 2 times n, which is 5, minus 1. So 2 times 5 is 10, minus 1 is 9. So if I continue this, what this dot, dot, dot means is keep doing it until I get to the last number. So I do 1, 3, 5, 7. These are all odd numbers, to 9. That should equal n, not this number, but that number, 5 squared. So it's just a formula that it kind of looks like one of those patterns we looked at earlier. And so if you take 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, 16 plus 5 is 25. So add those 5 numbers up, and I get 25, which equals 5 squared, which is 25. It works. So, you know, for something like that, it's not that much more work just to add them together. But if you had the number 1,000, n equals 1,000, therefore n, 2n minus 1 would be 1,999. You could add all the numbers up from 1 to 1,000, well actually 999, because 1,000, well, no, yeah, up to, you'd figure out what all the numbers you add together, and they would give you the result, and it'd be a lot easier to just use the right-hand side of the equation than, it's kind of like that Gauss's thing we looked at the other day where, you know, what's 1 plus 2 plus 3 plus 4 plus 5. Same, in this case, we're adding the odd numbers together instead of all the numbers up together. So, yeah, there's some formulas that you can use for shortening things if you want to. So again, what we did is I chose 5 just as an example. You plug n into here to find out how far we need to go, and then do the math on your calculator and see how they compare. Here's another one. It's kind of cool. So if you add up the numbers from 1 to some number n, whatever it is, and you square that sum, that equals each number by itself cubed. Why that is, I don't know. So again, this is an example of a rule, and you could apply that rule to any value of n that you wanted to. So let's pick an easy one that's not going to take too much time. I'm going to pick n equals 4. So what I'm going to do is move this up just a little bit. So there it is. Okay. So let's look at the specific case of n equals 4. So to use this formula, you would say 1 plus 2 plus 3 plus n, because that's the largest number, 4, is equal to 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. And let's see what we get. Oh, I forgot to square this here. Square that. So 1 plus 2 plus, do this. I can do this in my head, but I'm going to do it on my calculator just so that. Okay, so what you get in the number in the parentheses is 10, and you square that. And on the right-hand side, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and we just try it out, see if it works or not. So you get 100 equals, well, 64 plus 27 plus 8 plus 1 equals 100, so that works. Check. So again, any number n. So, you know, what would be, if it was a deductive reasoning, if I were to look at, you know, 3 examples, like 1 plus 2 plus 3 squared is equal to whatever those are at. 1 plus 2 plus 3 is 6. 6, or well, actually, so if I looked at, say, 3 or 4 examples using different values of n, and then I came up with this rule, that would be deductive reasoning. Or I could predict what the next item was. That would be deductive reasoning. I mean inductive reasoning, sorry. Inductive reasoning, because I'm doing experiments and then thinking what the formula is. In this case, they're giving you the formula, which is your rule, and you're applying it to a specific example, which I picked n equals 4. That would be deductive reasoning. Okay, so what this is sometimes I'll decide to do a few more problems, so they're out of your book. So don't write those down. I'm going to go ahead and give you the homework for section 2, which will be due not next Monday, because next Monday is Labor Day, but not the following. So it'll be next Wednesday. I'm not going to be in Monday. Neither are you. So, anybody got any exciting Labor Day? Anybody going to the beach? Nobody going to the beach. Anybody going anywhere? What's that? You didn't know it was a holiday? Oh yeah. Yeah, we didn't used to do Labor Day, but like two years ago they started doing Labor Day, which is nice. So we decided to go to New York City to visit our grandchildren. So that's a busy weekend. 435 miles each way. Pardon me? Are you going to bring us back? Oh yeah, if you want to see some pictures, definitely. Because they are the cutest grandchildren ever, so of course. Oh, by the way, here's a sales pitch. 2 years ago, I was the sponsor for the Glee Club, and we tried to do it last year, but there was not enough interest. We have some people who have already expressed interest. Kenzie up here apparently sings, so she's and Katie Lee, who's not here. She's probably, I don't see her online. She's probably going, I can't get online. She's also expressed interest. So if anybody is a singer, and basically what we'll do is we'll get the people who are interested and get together and see what you guys want to do. So it's just I am the facilitator. I also sing, so I might participate a little bit. I didn't last time, but we'd probably meet during this Monday time there's nobody scheduled. And what kind of music, it all depends on what people's interests are. So what kind of music do you like? Anything bluegrass. Okay. Uh, yeah, so I've sung in the church choir, sung in the local choir. I play the guitar and sing some there. My secret, you have these secret things. Well, it's not really a secret, but things you'd like to do, but you don't know it'll ever happen. So, two things relating to singing. One is if you, in England, they have these very old cathedrals, and each cathedral has a cathedral choir, and they sing old church music, and I like that. And so I would like to be in a choir like that, which is never going to happen. And the second thing is Broadway. I like to sing Broadway stuff. So since our daughter lives in New York, even before that, we've seen quite a few Broadway shows, and I love Broadway. Yes. Oh, okay. Are you obsessed? Yeah, I haven't actually. I've just seen snippets of the music, but my favorites are Les Miserables. I could sing parts for that for you in my show voice if I wanted to. I'm not quite as good as I used to be, but what's that? Do it. Yes. Not right now. No, you're right on the spot. No, don't do it to me. I need some words. But there's a certain Broadway voice you've got. You know what it's like? Yeah. No, I'll do it for you one day, but I'm not today. I need to practice a little bit. I like that. Do you know Les Miserables? Okay. So I like Empty Tables. I like to sing that, and the one that goes. It's when they're meeting it's before they're killed, and it goes. It is now it is time for us to decide who we are. Whatever that one song is. I like that one too. And then Marius comes back and he's in love, and anyway, that's obviously I know that play. And if you ever get a chance to see it live, do it. Okay. So let's, if you have your book, just open it up to Chapter 1, Section 2. And also, when you turn your homework in, write down the chapter and the section. Don't write the page number because that means nothing to me, and I have to then look it up. So, okay, so let's just see what we've got here. Yeah, so the first 20 exercises are basically looking at, well, the first 12 are saying whether it's arithmetic or geometric and predicting the next number. So let's just do one more. I don't want to belabor this too much, so we'll do number 4. So how I'm going to do this is I'm going to put a page here, and we're just going to look at the problems. So problem number 4 says 2, 12, 72, 432, 2,592. So the question is it a geometric or is it an arithmetic sequence? Well, this one should be easy because there's not a common difference between the terms, so it's not arithmetic. So it must be the other one. And to find the next item, you have to figure out what is the common ratio. So anybody see what the common ratio is? 6, yeah. So 6 is the common ratio. Therefore, the next number is, I'm going to ask Mary Jo. You got your calculator ready? Yes. $15,552. Anybody agree with that? Because I didn't use my calculator, so relying on looks in the ballpark. Okay, so we didn't write it down, but it's geometric. Common ratio 6. Okay. If it was if the difference between successive terms was a constant, then it would be arithmetic, and you just add the number. You wouldn't multiply the number. Okay, what's the next? We'll skip 7. 7, well, if you see it in your book, it's geometric series don't have to be increasing. They can be decreasing as far as magnitude. So that's what 7 is. That's interesting. Oh, okay, the next term. Okay. Then you have some method of successive difference problems, but I'm not going to do those in class. They take too long. And then you have some other examples of slightly more complicated expressions, and you're supposed to predict the next one. We've done that already, so that's pretty much it. Does anybody have any, whether you like to see any of those kinds of problems, or would you like to move on to the next section? I don't want to bore you guys. So what I'll say is, do the homework. If you get through the homework and you'd still like to see some additional stuff, then we can do some more. Sure. Okay, so the answer can be arithmetic, geometric, or neither. So number 10 is a neither. So you go 0, 1, 1. Oops, sorry. So it's not arithmetic because there's not a common difference between the terms, and there's no common ratio. So it's neither. But actually, this is a beginning of a well-known sequence. Does anybody remember what it's called? Or have you ever seen it before? Or maybe could you predict the next number? Pardon me? Yeah, exactly. Yeah. So the sequence is you take these two numbers and add them together, and you get the third number. And then you add these two numbers and you get that. And then you add these two numbers and you get that. So if you keep doing that, you will get this particular sequence. Pardon me? It's called, we'll talk about it another time, but it's called the Fibonacci sequence. And why is it called Fibonacci? Because that's the guy who came up with it. And is there any usefulness for it? Well, actually, surprisingly, there is to some extent. Because, as Miranda said, right? Yes, Miranda said, if you look at a spiral or like a snail or something that grows in nature, so there are natural things that sometimes the proportion of different sizes is equal to the number you get when you go to a very large number in the Fibonacci sequence. So what you do is you take the ratio of the two adjacent numbers. So 2 over 1 is 2, 3 over 2 is a half, 5 over 2 is 1.6, and you keep doing that, and once you get out to a very large number, it's 1.6 something or other, and that ratio is called the golden ratio, and it we'll talk about this. You don't have to worry about it right now, but next time you hear it, you'll say, oh, yeah, I remember that. So it has some in nature, and also people sometimes use it in architecture about the ratio of sides is a more pleasing ratio. So it's a Fibonacci sequence, not a geometric sequence or an arithmetic sequence. So you just say neither. Sure. Oh, determine the next probable term. Oh, yeah. Is that the one? Yeah, 19. So it's 3, 6, 9, 15, 24, 39, and something. So it's, you know, you start off and you think it's a geometric series, but then it's not. Actually, it's kind of like the one we just looked at, except it's starting with two different numbers. So 3 plus 6 is 9, this plus that is that plus that. So it's kind of a modified Fibonacci sequence. So, you know, they're just asking for the number. So you don't have to come up with a rule or anything like that, how you would describe. You don't have to add the two previous numbers to get the next number. Yeah. So, yeah, I don't know if, I mean, this is the Fibonacci sequence. This is sort of like it, but I don't think you would call it a pseudo Fibonacci sequence or something like that. And obviously you don't know what that is when you do the problem, so they just were asking you to figure out what the next number would be, which would be 63, I guess. I could tell you when the first test is going to be. It is going to be September 12th. And the reason is because I have to have a test done. I'm not dying or anything, don't worry. I have to go to the hospital for a test. And it's on that day, and it's going to take, I will not be available that day. You might guess what it is if you know anything, but anyway, I will not be able to move too much that day. But anyway, so I figured it was a good day to give a test. So what I'll do is I'll have somebody bring it in. I'll have everybody sit so there's a space in between. And whatever, you know, when we get to the end of next week or the beginning of the following week, I will figure out how far we're going to be along, and then we'll decide how much to put on the test. So it'll be into Chapter 2, but I don't know exactly how far yet. Depends on how things go. Because, you know, right now we're ahead of the Tuesday class because we're Monday, but because we don't have Labor Day, you'll slip to behind it. So let me write that down for you, just in case you forgot. September 12th. Just so you know, put that on your calendar. It's only 4 sections, and oh, there's a question here. Somebody beeped. So somebody must. Oh, there's Jessie. Oh, okay. I don't know why it beeped. Usually she. Yeah. Jessie. Jessie had me last semester, so she knows how to do it. She also works, and so. Sometimes she tends to line. Well, I was actually surprised. I'm surprised to see you today, Jessie. But she watches the recording at other times. So, okay, where was I? Oh, okay. So the next 2 sections, it's there's not a lot of numbers involved, and so this section is going to talk about problem solving, which there's a lot of generalized statements that I'm going to talk about. I'm not going to spend a huge amount of time on it. There are some homework problems. You're probably going to have to watch the video to know how to do them. It's kind of ironic because it's funny. I mean, it's the 3rd section of the 1st chapter. So, and then they give you the homework problems. And if you look at the homework problems for section 3, it says, one of the most popular features of the journal Mathematics Teacher, published by the National Council of Teachers of Mathematics, is the monthly calendar. It provides an interesting, unusual, and challenging problem for each day of the month. So they give you those problems to do, you know, problems, challenging problems for math teachers. So they can be actually quite difficult. So the reason I'm asking you is just watch, because it's just some examples of the thought process that goes through solving problems. And I could spend weeks and weeks and weeks trying to get you even somewhat proficient at solving these problems. Some of them I don't even know what I'm doing. So, pardon me? Oh, they're on the, when I put it on your memory stick. Yeah. So you just basically you'll look at the most probably you'll probably look at them for homework and you go, I have no idea what to do. Okay. That I'd say probably 80% of you at least will go, I have no idea what to do. So then you watch the video and you'll say, oh, okay. I still would have no idea how to do that, but it's interesting how that actually was solved. So I'm just warning you. So what we're going to do is we're just going to talk about some general things related to problem solving. So you don't have to write all this stuff down. We're actually doing this, we're not following this particular procedure in physics, but it's basically, I'm teaching them how to solve problems, but they really do need to know how to solve problems. So I think the problem with people who are not good at solving problems is if there's more than one step, they get freaked out. And secondly is they try to solve it all at one time. And most problems that are more difficult than simple problems require you to kind of break it down into little pieces and then attack each one of those pieces separately. And you have to be patient and confident that you're going to come up with a solution. So here are the steps, whoever this guy is. Polyaz's 4-step method for problem solving. I don't think he's that old. He's probably, so it's not like, this is not a Greek guy. It's somebody who's reasonably new. So it says understand the problem. If you cannot solve a problem, if you do not understand what you're asked to find out, the problem must be read and analyzed carefully. You may need to read it several times. After you've done so, ask yourself, what must I find? Okay. Again, so people read the problem one time and they like, I have no idea what to do. So don't feel like, it's not like reading a novel. It's solving the problem. So you may have to read it multiple times, each time trying to answer a different question. What are they asking for? What do they give me? How do I get from what they give me to what they want? So then you say, okay, well, how the heck am I going to solve this problem? Well, sometimes it's not obvious. In the case of math textbooks, a lot of times you look for examples that they have done in the book. You go back and look and you say, okay, let me see what they've shown me how to do, and maybe I can figure it out. Okay, that's not a sign of being not reading the text, but more careful enough. It's just that's what you have to do. I do it all the time. So you come up with a plan. You try the plan, then you get an answer, hopefully. But you may, the first plan that you choose may not be exactly right. You don't want to do something like build a deck or something, or remodel your bathroom with that kind of plan. You don't want to get to the end and find out, oops, I did it wrong. That's why you become apprentice and you learn the right way to do it and do it over again, over and over again. But at some point, if you're, say, a contractor, you do a lot of stuff and then it's slightly different and you say, oh, I think I can, I haven't exactly done this kind of thing before, but it kind of reminds me of something I did do, and I can, that's why you hire contractors who have a lot of experience. So you try it, and you may run into dead ends. It may not immediately happen. Now for you guys, most of the problems we're doing in this class are fairly straightforward, but the ones in this particular section may be more challenging. And then once you get an answer, if you have an answer in the back of the book, that's nice. But sometimes you can go back and check to see whether the answer you got makes sense. Is it on the order of magnitude that makes sense? Meaning, is it about the same size as what you would think makes sense? If we come up with a fraction of people, like less than one person, then that's probably not a good solution. So that's some general ideas about problem solving. And here's some more hints. Make a table or chart, draw a picture. We did that when I was talking in physics today. That's what we did. One of the first steps is you draw a picture, because visualizing something can help you get to the solution. Look for a pattern. We've been doing that recently using inductive reasoning. Solve a simpler problem. So that's why you have, again, math textbooks there's a reason they do what they do. Like I said, they put together examples for one thing, and then typically if you go through the homework problems, they start out with easy ones. You do the easy ones first, and then you get a little harder, and then you get a little harder, and then, So you can look back and solve a simpler problem, or if the teacher gives you simpler problems, you wouldn't want to start out at the hardest problem to start with. You don't always start with the problem at the last one. Use inductive reasoning. If there's an equation, try it and see what you get. Working backwards, that's a little hard to explain. Sometimes you can just guess a number for a solution and see if it makes sense. At least you know where you're going. If you have that's why if you have an answer, it's so much based on being an engineer. You go back to you look at the problem and you're like, I have no idea what to do. Let me look in the back of the book, and they give you the answer. And at least you say, okay, well at least I know where I'm going approximately. And that's just that knowledge that you know about where you need to get to helps you figure out how to get to the answer. Trial and error. Sometimes when you think a problem is really hard, there's a trick. Okay, so that happens in calculus a lot. Is somebody will start. It's not a catch, but they'll work the problem, and then they'll take 20 minutes to work a problem. And obviously, I'm not going to give, if there are 20 problems on the test, I'm not going to give each one's worth is going to take you 20 minutes. So if you start working a problem and it's taking you a lot longer than you think it should take you, then you probably have made a mistake. So it's time to regroup. It's like when a man is driving and he doesn't want to ask for directions, so he keeps going and gets lost, more lost, and more lost, and instead of stopping and asking somebody or going back to where they started. So that was it. Okay. You're like, that was short. This first chapter is unique in that way. So don't think I'm going to do that all the time. He just skips over everything. I can't believe that guy. Don't worry. Yeah. Actually, the number 5 is a sign, but I'm going to just talk about that one to get you started, so we can talk about it in the class. So again, if you have your book, I'll write it out I'm not going to write it word for word. I'm going to give you paraphrase it. Okay, so here's a little, that has nothing to do with math. This is just a middle of the class. Don't use smartphone. So I think I told you guys that my family is from England, and I am a British citizen. I moved here when I was 5, hence no accent. But so I listen to this radio. You can stream. It's great nowadays. You can stream radio stations. And I listen to this radio station that's from the area of my schools in an athletic conference compete in a cross-country meet, to which each school sends 3 participants. Aaron, Caitlin, and Ileana are the 3 representatives from one school. So then they tell you information about where they finish. It says Aaron finishes the race in the middle position. So let's write that down. So Aaron with an E. Caitlin finishes after Aaron. Caitlin with a K. So this is number 5. And Ileana, one in, finishes 28th. How many schools took part in the race? Okay. So, the question, so it's, there's no formula for this. So how do you approach this? Yeah, well so where is the middle? Yes. So you have as many runners less than you as greater than you. So how many, are the number of racers going to be odd or even based on that statement? If Aaron, Caitlin, or Aaron is in the middle. So if she's the middle and they're an even number on one side and an even number on the, well, they don't have to be even, but they have to be, the total has to be even outside of that. So that means there are odd number of racers, right? Because they can't, if there were an even number of races, you'd have 2 people in the middle and not 1 person in the middle. Okay, let me just, nobody's going like, yeah, that's interesting. You're like, what? That's why I said, these are not easy. So let's say you have 6 racers. So you'd have 1, 2, 3, 4, 5, 6. If you have 5 racers, then you'd have 1, 2, 3, 4, 5. So the middle of the racers would be here. So if you'd have to say either 2 people are in the middle or none are in the middle. Whereas with 5 races, you have a middle. So that means that the number of racers has to be odd. Okay, now, what else can you say about the total number of racers that are running in this race? Are they a multiple of any number? There are 3 runners per team. So the number of racers has to be a multiple of 3. Okay? So let's just kind of write this down as what we guess what they could. Whoop. So you could have 3, you could have 6, you could have 9, you could have 12, 15, 18, 21, 24, 27, 30, 33, 36. The answer is less than 40. So, well, they can't be these ones because then there'd be no middle. So they have to be those, right? So those are my choices, 6, 9, 15, 21, 27, 33, 39, because they have to be multiples of 3, and they have to be odd. So we've reduced it down from 40 people down to 1, 2, 3, 4, 5, 6, 7. There's 7 options. So let me delete this page. So now, so Ileana finishes 28th. So there have to at least be 28 people, right? She can't, if there's only 26 runners, you can't finish 28th. So that gets rid, that particular piece of information is used for getting rid of this one, this one, this one, this one, and that one. So trying to think about that. So let's see, Ileana is in 28th place. If oh, 19th position. Okay. So that's Caitlin is here, and it's the, oh, she finishes after, oh, she actually, they give her position. Okay, I was thinking there was something missing there that would help us. Okay, Caitlin finishes after Aaron in 19th place. Okay, that's one additional place, because otherwise you could probably keep going on higher multiples. But so our two choices here are 33 and 39. So let's think about that. Does 33 work? So yes, if you have Caitlin, the middle position would be number 17, I think. 17, because you have 16, then 17, then you have another 16 afterwards, which would be 33. So in that case, there's enough people, so the middle position places Aaron in the middle with Caitlin after Aaron in 19th place. And then you have, in the next position is Ileana, which is 28th. Now why 39 might not work? Well, the reason 39 wouldn't work because the middle position there would be 19, which is the same place that Caitlin gets, and so that eliminates 39. Okay, so that's why 33 works and all the other ones don't. So let's review what we did here. We said because each school has 3 runners, the number of runners has to be, so there's 33 people, which means 11 teams. Okay, that's the answer is 11. There are 11 teams. So the fact that there are 3 participants per school, the number of participants has to be multiples of 3. Then, because the middle position only happens when you have an odd number of runners, we can eliminate all the even choices, 6, 12, 18, 24, 30, and 36. Then we know that there are at least 28 runners, so we know that we can get rid of everything less than 28 outright. So that left us with 33 and 39. 33 works. 39 doesn't work because then we'd have Caitlin and Aaron at the same position, which is not what happens. She finishes after. So it's kind of a roundabout way of doing it. You know, I'm writing down numbers here. I'm not trying to remember things all in my head. I'm trying to eliminate stuff to come to a final solution. So anyway, there's your whole, I did it for you. So now you can read it and do it again when you do it the other day. That was one I got. Some of them I didn't get. I don't think I assigned any of those to you. So if I couldn't do it, then I wasn't going to ask you to do it. time is it here? 1:50 something. Has anybody ever done any genealogy? What's that? Genealogy? Yeah. You kind of do the same thing with the genealogy sometimes if you're tracing your ancestors back. Because has anybody ever watched those things on TV, the genealogy shows like Who Do You Think You Are, or what's a Genealogy Roadshow, whatever, and you see those. And you know, because my family's from England, there's, in some ways it's easier because back there was laws that required people to be, all marriages and births to be met, or christenings to be recorded by the churches, even before the civil requirements were, there were church requirements. And so you can go back and you can look that stuff up. But you know, figuring out who the father and the mother are of a child, you do things like you look at census records, and census records tell you the person's name, where they were born, and how old they are. So what you do is you take that information, subtract how old they are from the date the census was taken, then you have the birth date, and then you have the birth location. So then you go into different records and you say, you search for people named this who were born here this date, and you may get, and it's amazing how you eliminate a lot of, it doesn't take too many things to eliminate people who are not your relatives. So you can actually go back pretty far as long as there are records, but it's the same kind of puzzle. Maybe that's why I like it to some extent. Yep, go ahead. Gauss theory, yeah. Okay, sure. Yeah, so the idea was if you add the numbers from 1 to up to some number, what is the sum of those numbers, doing it quickly instead of doing it a long way. So I'm going to pick a smaller number here. Let's say I want to add the numbers from 1 to 50. What's the answer? So the idea is you recognize that if I take the first and the last and the second and the next to last and so forth and so on, all of these you can just add the first and the last together and you get 51. And so this pair equals 51 and this pair equals 51. And so because there are 50 numbers, there are 50 divided by 2 pairs that add to 51. So the answer is going to be 50 divided by 2, which is 25, times the sum of the pairs, and then you just multiply those two numbers together. So you get 25 times 51 is 1,275. So when you see something like this, basically you just add the first and last number, multiply it by the last number divided by 2, and it just saves you a lot of time. So that's how that works. That's Gauss's, I don't know if it's called Gauss's theorem or just Gauss, we'll just say it's Gauss's thingy-diggy. No. Gauss's method. Just using inductive reasoning, because you're observing that the first and last add to the same number as the second and next to last, and then you can come up with a rule. The rule is that, and that number is not 57. It kind of looks like that, but it's 51. Yep. Yeah, genealogy in England is interesting compared to America. America for hundreds of years was more of an agrarian society. You know, farmers, had more farmers, and then the Industrial Revolution came, and there were people that worked in the factories and things like that. In England, it's much different because the people who owned the land were not the farmers. So when you had too many farmers, then they sent them to the cities, and they did interest jobs more so different than what if you look in America. So my family comes not from royalty. I'm not, I always find somebody, oh, I'm related to king whatever. Well, I have no relatives that are kings. I had a coal miner, a servant in a household. Does anybody watch Downton Abbey? You got any Downton Abbey people in here? Anyway, if you like Harry Potter, you should watch Downton Abbey. Anyway, it's about a upper class family with the servants working for them. So it's good to know where you came from and be appreciative of where you are now. Okay, anyway, that's. Okay, so the last section is titled Calculating, Estimating, and Reading Graphs. So how many people would say that if I were to show you a graph with some data, how many people would feel like, yeah, I think I can figure out what that graph says or means? Okay, so as a few of you feel comfortable with that. To be honest, that is probably one of the most useful math skills that you'll ever learn, because the reality of life today is that you're fed a lot of information that is probably a lie. And to be able to be an informed citizen and also a good consumer, you need to be able to yourself figure out whether something is a lie or the truth. Back in the older days, you had books, you had newspapers. Most newspapers, when they presented something, they went through there were still bad newspapers back in the old days, but you had to look at it, and the people who were running it had some kind of criteria they went by to determine whether to publish it or not, if it's true or not true. That's not, there was a lot of, like I said, stuff that wasn't true, but today with the internet, anybody can publish anything, or anybody can say anything, like this guy up at Lake Mumau. Did anybody go to his Facebook page and see his thing? That was the first thing I did. I saw the guy's name, and I said, I'm going to check him out on Facebook. Pardon me? I'm not sure if it's still on Facebook. Yeah. Oh, okay. So yesterday, yeah, that's the guy. Yeah, so anyway, the story, it's not a story. So my wife says, it's funny, she doesn't have a Facebook account, but she always looks at my Facebook because she likes to see what's going on. So I don't know what that means. But she goes, somebody just posted about that they've closed off Lake Mumau because there's some incident going on. So so then I said, okay, let's check the news, and they said, the police, I said, there's an incident going on. What is the incident? Nobody knew. So I checked back a little bit later, and they said, police have arrested blah, 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 the guy's name. So that first thing I did was I searched for, well, actually I went to Facebook because I figured otherwise. And so, I saw the little video saying that God had talked to him or whatever it was, and he had been anointed and stuff like that. So what this guy was doing, and let me correct me if you have a different feeling of the situation. I think he went to Lake Mumal with an assault rifle and a body armor, full body armor. Get above the dam. So he was going around trying to recruit people to help protect the dam. Yeah, that's what I heard, the PTSD. Yeah, so that was what our daughter called and said, just checking to make sure you aren't up at Lake Miwok. I go, no, we're okay. So anyway, that was the thing. So I'm just using that as a current example of, people have outlets to say anything that may or may not be true. I used to get, back in the old days when people actually read their email, I used to get these things forwarded from somebody I worked with. And they were usually a conservative position. And I would go and I would look at it, and then I would go check to see whether it was real or not. And 95% of the time it was incorrect. It wasn't, either it was a complete lie or it was a stretching of the truth. Nowadays it's mostly people like or forward something on Facebook, which turns out not to be true either. So the bottom line is, don't believe it. You have to, unless you just want to reinforce your view without looking at the facts, then that's fine. As long as you realize that's what you're doing, you're not actually passing on facts. So, understanding what is true and what's not true is a skill that is very important nowadays. So, besides looking at the sources and checking to see, well, so here's another one. Has anybody ever checked anything on Snopes? Snopes is a website. And so, of course, somebody who doesn't like that Snopes is telling people that everything that's alt-right is usually made up, or something along those lines, is a little stretch of the truth. So then somebody posted a thing about Snopes saying you can't trust Snopes. So if you can't trust Snopes, then all that stuff. Anyway, it turned out then somebody did a fact check on that to see whether Snopes was accurate, and they said it was accurate. So anyway. So from a math standpoint, sometimes you can look at what you consider to be data, somebody presenting data, but they can twist it so that it satisfies their opinion, whether it's right or left, conservative, liberal, they all do it. So reading graphs, understanding data is something that's important. So we're just going to look at, first I'm going to use some examples that are in the book, and then I'm just going to randomly pick some stuff off the internet, and we're going to look at it. We're not going to be able to do that all today because we only have 6 minutes left. So here's, I'm just going to, as a review of different kinds of graphs. So this is a pie chart, and you can see there's a title. There is, so the total circle represents all of the possible occurrences of whatever they're looking at, which in this case is immigrants by region of birth, which actually has some relevance right now. I'm there. I'm one of those guys. So, each part of the pie, each proportion of the pie represents, in this case, how many were born in Latin America, your Mexican drug rapists and stuff that Trump says, the Europeans, me, other, Asia, whatever. Okay, sometimes they give you the actual total number, but sometimes they just are showing you a percentage. So the total will be 100%. And if you add those all up, you can actually figure out what the other would be. What percentage are other? Anybody figure that out? Do a little math in your head. What's that? 5%, yeah. Yeah, so the other is 5%. So that's a typical kind of graph. This is the one that I use the most when I'm doing stuff. So it's anybody know what this kind of graph is called? So it's what are these little things called? Bar, yeah. So it's a bar graph. There's horizontal bar graphs. There's a vertical bar graphs. This is a vertical bar graph. And so what it is the number of pounds of milk production as a function of the year of production. And they're using an abbreviation for the year once they've established that the first two digits don't change. And so again, you can make some general conclusions about this. You can say, in general, the amount of milk being produced is increasing from year to year. You could say the year that milk production increased the most, from what year to what year is the production increased the most based on that graph? Yeah, or 04, 05. Here's another question for you. What are the consequences of this happening from a farmer's standpoint? So if they keep making more milk, what do they have to do otherwise? If they keep making it, they're going to have to sell it, right? If you don't sell it, then the price goes down. If the price goes down, then you don't make any money, and so you go out of business. And so it's amazing how cheap milk is. You ever think about that? Does anybody buy groceries in here? I'm the grocery shopper in our house, and I go there and I think, how can you buy a gallon of milk for $2.89 or whatever it is? So Jessie, she works at Food Line. So how can you make milk for $2? I mean, how can you sell it? Well, there's subsidies and stuff like that, but and then you buy bottled water for something. What is water? We'd have to filter the water to make, or milk to get water, sell to a higher price. It's just crazy sometimes, the things going on. I'm glad it's that price for me because I don't want to spend the money, but so there are a lot of things you can do. Notice one thing that's a little tricky here is how you set the scale. They've actually got 0 here, and this is 160. So this is not to scale, and so sometimes people do that. They use the scale to make it look like what they want. I didn't notice that at first. So got to be careful about scale. So we'll talk more about this next time. There'll be a project, a computer project that you will do, and you'll learn how to use Google Docs to do a graph. But I will give you plenty of help. Timber can tell you that, right? I give plenty of help, so don't worry about it. If you've never used it before, you'll still be okay. Okay, we'll see you on Wednesday. If anybody wants to, oh, by the way, if anybody wants to sing besides Kenzie and Katie Lee, come and see me. If I get 5 people, I'll sing to you. I'm just kidding.
Did you want to write out the questions? Or is that okay?
That's fine. You don't need to write the questions. Okay. Oh, that's right. Somebody gave me this earlier. Who the heck was that? Whoever gave me the memo. Oh, that was you. Okay. Okay. There's yours. Do you have a class after this?
Yeah, at 2:30.
2:30. Okay. It'll take about 5 to 10 minutes, so I'm afraid I can start it. The homework or the memory stick? Yeah, you can give it to me tomorrow. You can give it to me now, and I'll give it to you tomorrow. Okay. Yeah. What I'm going to do is I'm going to start yours, and then I'm going to walk to my office, and so I can get out of here. Okay. You are funny.